recording just so it's on. Okay, Jim, so we are live and I will let you open this up. And just to everyone in attendance, just know that we have a chat function as well as a Q&A function. If you have any questions, you can go to the Q&A function and I will do my best to field them back to the presenters. And with that, I will let Jim, I will let you take it away and begin this.
Okay. All right, welcome everyone, and thank you for joining us on this first Friday of October, which is our manufacturing day. This month has been celebrated for the last 9 years as Manufacturing Day and Manufacturing Month. So we're excited about having you here and doing this in a little different way. 2020 seems to be the virtual year. So that's who we are. And like Jim said, if you have questions along the way, please put those in the chat and or in the Q&A, and we'll try to answer those as we're going through. So today, I want to welcome our panel and welcome all of our guests that have joined today. If you're in class, if you're a student, really excited for you to be part of this. If you're a manufacturer, I'm extremely excited that you're doing what you do and that we are able to support you and try to help build momentum for manufacturing in America. So today, our panel is basically going to be myself. I'm Jim Lawson. I'm an industrial coordinator here at Pontotoc Technology Center in Ada, Oklahoma. And then we have John Paul Townsend, who is with GAMI, General Aviation Modifications Inc, and Tornado Alley Turbo. And we have Steve Chandlin, who's also a test engineer for GAMI. And then we have Jim Eldridge, who is our Economic Development Director here in Ada. So welcome to all of them, and we'll be your panel today during this presentation. So just so you kind of get an idea what we're going to do today, I've got a little bit of information to share with you. We're going to do a virtual tour with John Paul and with Steve, and then we'll have a little Q&A session at the end. Hopefully you have some things in the chat that you'd like to ask questions about, and we're excited to try to answer those. So with all that said, Jim, if we'll go to that first slide, we'll start off with this. So just so you all know, there are some things you need to know. Most of the workforce right now in skilled labor is of an age that's nearing retirement, or by 2030, 3/4 of them will be gone and out of the workforce. So there's a lot of opportunity in manufacturing and manufacturing jobs for skilled and trained professionals. And we'd like to make sure that you understand that the education that you're getting these days, that it's extremely important that you take that a little bit seriously and kind of think about manufacturing as being an opportunity for you. In the past, manufacturing has been thought of as being a dirty, low-level job. It's quite the opposite in today's world. It's high-tech, high-skilled, and it is extremely important to our nation's economy, and it's a great job. That sector of jobs is known to produce a lot of wealth for the country, and its people make a lot of, their salaries are really, really good. So there's tons of opportunity in manufacturing, and definitely want you to think about that as being a possible career, at least a possible career path. Next slide, please. There's jobs in manufacturing. So you want to be a doctor or a lawyer, an engineer, accountant, whatever it might be. You can work in the manufacturing industry and sector, even though you're doing those types of jobs. You can also be a welder, assembler, electrical technician, a maintenance tech. These are all direct jobs at one of the manufacturing plants. But not only are those jobs, but there are a lot of professional career jobs that are tied to manufacturing as well. So a lot of people don't think about that, and they earn really high wages. Currently, about $84,000 annually is what's expected. These are really big numbers. So definitely something that we want to think about as a career for you. Next slide, please. Wages in manufacturing, they look something like this. Jim, you'll have to hit the button. Starting wages look about $25K annually. Now I'm talking about jobs here that are very basic, require almost no educational background other than a high school diploma, and they're entry level, so you may not even have skills in that industry. Next. When you get a few more skills, so some of the advanced wages in those beginning areas, if you've got some previous experience, might be as much as $37,000 to $40,000 a year. Next, please. Management, you can expect in management, if you want to be a manager of a department inside a manufacturing plant, you're normally looking at about $40,000 a year to start with, and those numbers are definitely going to go up with experience. Next, please. High demand technical careers, especially maintenance techs, electrical, programming, that type of thing. You're looking at numbers pushing $100,000 a year. Next, please. And executives, if you work your way up through the ranks and become a plant manager or one of the executives at a plant, it's almost unlimited there. Some corporations are paying in the millions for the people leading them. On average, you're looking about close to $100,000 according to ZipRecruiter. Next slide, please. Some of the education requirements that you can expect: high school diploma to doctorate degrees, depending on what you want to do while you're there. Next, please. A line worker, you're looking at high school diploma, and then the next level up from that. Next, please, Jim. Supervision, a lot of times technical degrees with only 2 years of education and a technical degree will get you into that next level. The next level, of course, is going to be more of a engineer, accountant, manager, executive, etc. 4-year degree, again, stepping you up in the ranks there. So the more education, the more chance that you have, the more skills that you have and possess, the better opportunity you're going to have for advancement in the company and a higher wage. And advanced engineering scientists, lawyers, etc., they may have as much as 8 years of education, and they're going to do really well in these manufacturing plants. Next, please. So what kind of cost are you looking at for education? Most of us don't think that much about the cost of education, but in today's world, it is really, really expensive. You're looking at here at Pontotoc Technology Center, if you're a high school student, a junior or a senior, you can come to our school free of charge if you're within our district. Technical training can cost up to over $30,000 if you're an adult. And a university, you can spend anywhere from $40,000 to $250,000, depending on how much and what school you go to. So your performance in high school and your performance on your test, entry-level tests, entry exam tests, is extremely important for you to get scholarships. There are scholarships out there, but it does require you to put some effort out and to apply for them and score well. And normally they're going to be looking at things like what kind of student are you in high school? Next. Next slide, please. There we go. One of the things that I've been told, and I spend a lot of my time making my way around manufacturing plants, visiting with the people that do the hiring there and that really are the ones making sure that they have the staff that they need. And one of the things that I've been told time and time again is that they will really hire for attitude. And if they can find somebody that fits the culture and fits in with the group, they'll find a way to help train them to be at a level that's productive and good. So it's important that you have the right kind of attitude, a positive attitude toward work, and that your soft skills is what we would call them in education, which is showing up for work on time, not abusing your sick leave, and being ready to work and take on new projects and take a leadership role. Next slide, please. Manufacturing has a huge contribution to the gross national product and to the economy. Almost over $2.33 trillion contributed by manufacturing. And that basically means that if manufacturing spends $1, they're going to get almost $2 back from that dollar that they spend. So manufacturing is where the growth and where the wealth of our nation is. And so it's grown close to 10% since 2002. That number will continue to grow. This time of the year, or I guess this time in history, is one of the biggest times and most advantageous for manufacturing in America. The idea of bringing back manufacturing into America is huge right now, with a lot of support from the political side. So I think we stand to have a really, really large influx of manufacturing into this into our economy. So it's a great time to consider getting into manufacturing, because I think that's where the jobs really are going to be. Next slide, please. Manufacturing is the creators of wealth. No doubt about that. When you create a job in manufacturing, you create almost 3 other jobs in other support structure around the plant. For example, if you put in a manufacturing plant, there generally will be other support companies that pop up, and they can be as simple as a new sandwich shop, or they could be as complex as a supply chain supplier for that manufacturing plant. So these are big, big numbers. 3 for 1, that's a huge return. Next slide, please. So today I'm going to have a couple of challenges for you. So what are you passionate and driven to do? This is your call to action. What do you really want to do, and how are you really going to do it? I challenge you to consider manufacturing as a career path, no matter what it is that you're wanting to be, whether it's a doctor, a lawyer, or if you want to be a welder, an electrician, an HVAC tech. There's a job and there's a place for you in manufacturing, no matter what you want to be. Nurses, believe it or not, our plant, one of the plants I worked at, we had a doctor on staff, we had a nurse on staff. So lots and lots of areas for working like that. Next slide, please. So what new career are you going to discover in 2020? That's my challenge to you as students and as people looking to develop their career. My next thing I want to go to is I want to show you JP, John Paul Townsend, and GAMI. They're a manufacturer here in Ada. Let me tell you a little bit about them. GAMI was started in 1994 by a couple of aeronautical engineers, George Brawley and Tim Rail. Their efforts have been in fuel economy, developments of fuel for the general aviation industry, and advancements for the general aviation market. They are an excellent company with a lot of outstanding employees. We're really excited to have John Paul with us and his team. So let me tell you a little bit about John Paul. So John Paul was a graduated high school at Latta High School here in Ada. He then attended University of Texas for aerospace engineering. He then completed his education here at East Central University. And during that time, he was working as an intern with GAMI. And then eventually he went to work full time for them. And he's been there 24 years. So he's a very experienced guy. And I appreciate him taking time out of his day to be part of this. And he's going to take us on a tour of General Aviation Modifications Inc. and Tornado Alley Turbo. These are sister companies. So John Paul, I'll turn it over to you for our tour.
Thanks, Jim. So I'm real happy to be here, happy to be a part of this experiment. To everyone out there, thanks for showing up and watching. This is so my name's John Paul Townsend. Like Jim said, he didn't mention that I was a student at PTC during high school in a drafting and design program. That's really what led me to GAMI. Tim Rail and George Brawley, the founders of this company, were looking for someone to do some drafting of some parts, and that led to them coming to the VOTEC because they knew there was a good drafting program there, and there was some people that could accomplish those tasks, and that led to me being here and through college working part-time and ending up here after college. So our company is GAMI. That is an acronym for General Aviation Modifications Inc. And the name pretty much says what the business is. So general aviation is the small segment of aviation that is typically 2 to 4 place, or maybe as high as 8-seat airplanes. Our particular part of that is privately owned or light commercial airplanes that are all piston powered and propeller driven. So smaller than airliners, smaller than most charter organizations. This is your privately owned airplanes and your corporately owned airplanes that only take a few people on short trips. It's a, generally speaking, small segment of the aviation market, but it's a pretty important segment for all of those owners of those small airplanes. The aviation industry, or the general aviation industry anyway, is made up mostly of small manufacturing companies. There are a few big companies. The airframe and engine manufacturers are generally pretty big plants that may have a couple of thousand employees. The small manufacturers that make all of the little parts are generally some 2 to 4 person mom and pop shops to around 50, maybe as high as 100, but that's kind of a big shop in our industry. So our company, GAMI, and our sister company, Tornado Alley Turbo, together employ about 40 people, and we do certain modifications for certain types of those airplanes, one of which is in the background here. This is a Beechcraft Bonanza, and is one of the airplanes that we do most of our modifications for. So what I'm going to do today is I'm going to take you on just a real abridged tour of some of the things that we do here. We're going to take 15 or 20 minutes maybe and get some of the high points. We are spread out over a couple of buildings. So what I'm going to do is I'm going to show you a few things in this building, what we call our flow lab and a little bit of our engineering department. And then I'm going to switch over to Steve Sheldon in our facility and let him show you a few things while I transition to another building. And I'm going to attempt to pick up the feed at that point and show you our machine shop and our welding area and maybe our electronics area if I can get to that in time. Like I said, just a little taste of some of the things that we do here, and hopefully I can interest somebody in some of the things we do, and maybe somebody will see that and decide that's an area they want to pursue or something they're interested in. And obviously things are different right now as far as having in-person tours, but hopefully in the near future we'll get back to that, and we can have some students come out here and see the full tour and see all the things that we do, and maybe get some interest for some classes they offer at PTC. So let me show you. We're going to go right here, and I'll have my cameraman Dakota follow me. So one of our main products here is a small fuel injector. This is a fuel injector that goes in these engines. These engines they use a continuous flow injection system. So it's a type of mechanical fuel injection that is used throughout aviation. It's a very reliable system. Doesn't rely on electronic sensors and things like that. So it can be real robust, but it's not perfect. And there are some flow characteristics of these nozzles that can stand to be improved, and that can improve the efficiency of the operation of the engine. And this is our first real product. We started making this product in late 1995, and worldwide we've sold 29,000 of these kits of fuel injectors to airplanes all over the world. So wherever in the world you go that you see this size small airplane, if you talk to the operators of that airplane about GAMI ejectors in Ada, Oklahoma, they'll know exactly what you're talking about because these are pretty widely known in the industry. Now, we manufacture these in-house. We have a machine shop next door, and we'll get to that in a minute. But we set the flow rate of those in some machines that are here, and I'll take them here. This is a flow bench, and if you look at the screen here, we have some programming that we've done in-house. This is fuel flow and pressure, and tells us the flow of the fuel injectors, and you can see there's some calibration fluid coming out of these injectors here. This is pretty sophisticated stuff. We have flow sensors and pressure transducers that are real finely calibrated, and then all of these nozzles are flow checked, and then the flows of them are set with these very small pin reamers. These pin reamers are it's not really coming out very well. Pin reamers are revolute reamers that are spaced out in 2 10,000ths of an inch increments. This one's a 0.0320, so 4 decimal place precision. Every 2 10,000ths. That's make very fine adjustments to the orifice size of the fuel injector, and that's how we set the flows. And all of this stuff is computerized. All records are kept computerized. So if someone calls me 20 years from now and says, serial number, I know what it flowed the day it later. If we need to separate those or make adjustments to them, I have the data that was used at that time. If we look at the screen here, this is all programmed in a software called LabVIEW, a company called National Instruments out of Austin, Texas. You'll see more of this throughout our facility. It's a good data acquisition and control software, so we use it for both of those purposes. Data acquisition is where we are taking data from something else, and control is where we are manipulating something. So this is a visual programming language, and this is something that we have occasionally taught some classes at PTC, not recently, but we have done it in the past, where we've taught some classes on the operation of this. And each one of these symbols is analogous to a control or an indicator. This one here, if we double click on it, goes to this indicator here. So it's done a lot like a wiring diagram, and it is how we program all these sensors and get the data from them. And then in the test cell, you'll see where we actually output controls. So we take in data about temperatures, and we can then open up valves, close valves, open up airways, things like that. So very important piece of software for us. We develop it in-house, and that's another important factor for a company our size, is being able to do a lot of these manufacturing tasks in-house without having to farm that out to another company. So if you follow me, we'll go into the engineering department.
And JP, while you're walking, we had a couple of questions that we might answer. Stacy Oakley asked, how much does the airplane behind you cost, and what is the biggest airplane you've seen?
Okay, so an airplane like this, this design didn't change much from 1968 until the current model that's made, which is the 2020 models. They've made very little changes over the years. This one is a 1984 model, and it was a special model with a little bit longer wing, a few things like that. On the open market, in the configuration in which we bought it, about $295,000. When we bought it, it had a run-out engine, meaning the engine was in need of overhaul, and didn't have the paint or the interior. So I think we paid a little less than that. But our modifications that we do to the airplane adds about $100,000 in value. So if you were to buy an airplane just like this, equipped like this on the open market right now, that would be somewhere in the $350,000 to $400,000 ballpark, depending on how the avionics suite, which is the instruments in the cockpit, how that's configured. You can have some that are basically as they came in 1984, and you can update all that to be the newest and greatest, latest and greatest stuff, and that costs about $100,000 to do that upgrade. That doesn't mean that the value of the airplane goes up $100,000. The actual market value of the airplane is something on the order of 40 to 60% of that money that you spent on it when it comes to things like avionics, and that's a time-based thing. The further down the line you go, the newer avionics come out, and the older avionics become worth a little less money. This one in particular, if you look at the door, it's got an experimental sticker on it. So this airplane is in a special category, which is the experimental category. The purpose of that is so we can do some testing and modifications outside of the regular certified airplanes. So airplanes that are certified, they have to have a blessing from the FAA for all of the parts that are put on there. So all the parts we make at GAMI and the parts we put on at Tornado Alley, I'm trying to get out of that sun there. All the parts that we manufacture here at GAMI and put on at Tornado Alley, they are certified by the FAA as safe, airworthy components. Now, when we put an airplane like this in experimental, that means we can take products that we're developing and put on that airplane to test them out. Now, they still have to be certain certifications for safety and things like that, but it's not something that we can sell to the open market and anybody can put on their airplanes yet. And because those items are not yet certified for the airplane, we can't put them on our own airplanes to test them out for flight unless they're in experimental category. So we have several airplanes in the facility that are experimental category airplanes for that reason. This one in particular has been experimental for several reasons. It has our turbo system on it. It has a different propeller that is now certified. It has some changes to the way the turbo system is controlled. Currently, that's a oil-driven hydraulic analog system, and we've developed a digital electronic system for it that we're currently in the middle of getting certification for. So go this way. So this is some of our engineering department. Being the size company we are and the way this company works, you could look at it from one point of view that, this is all the engineering department. We do research and development throughout the whole facility, but this is the actual offices side of that where the drafting is done, that a lot of the design work is done. You can see we've got 3D printing capability. You can see over here there's a laser engraver we use to make some little placards that go on the airplanes. And then in here you can see some of our parts that we've done. We've got some 3D printed scoops. We've worked with the Fab Lab there at PTC in the development of some of these products. The Fab Lab at PTC has been really helpful. Jim Lawson and the crew there have helped us 3D print some of the items that are either too big for our printer or different materials that our printer won't do. This product, in fact, has a carbon fiber stranding in it, and they have a machine there that'll make carbon fiber in this plastic resin as a carrier. So it gives it a lot of strength, and it's very flexible and robust, but a lot of strength because of that carbon fiber. So doing some neat things at the Fab Lab there, and we're happy to be a part of that. You can see some other parts that we manufacture in-house or future products. These are some louvers. We make the dies, and we have a press that stamps these things out. Here are some other products. Here's a finished part that is actually a factory part. We make a part that's the replacement part for this. And here you can see one in its beginning formed piece. And when we go to the machine shop, I'll show you the die for that. If we look over here at Caleb, we can see a new product line that we've picked up from another company, which is a externally mounted fuel tank that goes on the wingtip of some of these airplanes. And a lot of these drawings from this company we picked up were from the 60s, and we need to update those. So that's been a lot of recreation of those drawings where we take and scan and trace and then alter the drawings and then make 3D representations of the parts, show them that moving around. So we make some 3D representations of the parts so we can go into manufacturing of our own, and some of that is going to involve new manufacturing techniques, more automation, things like that. So what I'm going to do at this time is I'm going to turn this over to Steve Sheldon in the test cell, and he's going to show you some things, some of the testing we do there, and some of the software we use, and some of the hardware. And then once we change buildings, I will pick up with you in a moment. what? Who was that for? Votech. Oh, yeah.
Am I unmuted now? My name's Steve Sheldon, and I'm out here in the GAMI test cell engine test facility where we run big airplane engines up on a test stand and test different things about them. Most recently, we've been working on an unleaded fuel for airplanes, and we're testing different mixtures and such in real airplane engines under very carefully controlled conditions. I'm a test engineer, and my title here is Test Cell Manager, and I make sure that the tests go according to plan. I think we'll go out and look at, we have two 300 horsepower engines mounted on stands out in a room out here. I think we'll go see if we can go take a look at those. Yeah. Let's see how this works. Yeah, that's pretty good. I guess it doesn't look like much, but we have this big engine here with about 60, 80 different kinds of sensors all stuck on there. These sensors are fed back to a panel, which is then fed back to 4 or 5 computers in the control room. And we read those sensors with software that we've written in-house. It's called LabVIEW, and it's made by National Instruments. And all these sensor data are logged onto the computer, and we examine them and scrutinize them and make sure that everything in the engine's doing what we want it to do. There's another engine over here, which is a nearly identical setup. It's a slightly different engine. We can mount any kind of engine we want up here. The propeller is in a shroud, and we have sensors, big blowers on the top that blow air down on the top of them, which simulates moving through the air and keeps them cool like they're in a real airplane. So we fool them into thinking that they're in a real airplane and then run them under different conditions and see how they do. Mostly right now, we want to see how our fuel is doing. So back in the control room, we have 4 or 5 computers all running software that read these sensors. The most interesting sensor is in the engine cylinder itself. There's 6 cylinders on these engines, and we have a spark plug which we designed and have Champion build. And this spark plug has a hole in it. Most of the time, you don't want to have a hole in your spark plug. But what we do is we take a pressure sensor. This sticks in the hole, and then fiber optics feed it back to the electronics part, which is then 3 wires sent back to the control room. Now here in the control room, we have a rack, and this is where all the signals come in from the engines. And then they're fed to our computer system. And we've developed LabVIEW software. You can show that. It's kind of hard to see, but that's the what the front of this is what we see when we're running the engine. And that's something, gives you an idea what the software looks like that we wrote in-house to handle all this stuff. Okay. So with this computer equipment, we can see real time how the engine's doing, if it's overheating or if the oil pressure is good, stuff like that. And it's all recorded. And we come back and analyze the recordings to see if the fuel that we made or other devices we're testing out on the engine are working according to what we want them to. I think that's all I have out here. Now, John Paul mentioned our electronic wastegate controller, which I think this is the front of it right here. Let's get this right here. This is version 1 that we developed in-house. We're kind of proud of this first prototype. And then we built a couple more and put one in the airplane that John Paul was showing you. That uses an embedded microcontroller inside there, which watches the pressure in the airplane and regulates the pressure to the upper deck according to the altitude and other conditions. And replacing that old driven wastegate controller that that we've been using for 40 years. We hope to get that done here soon. I think that's all I have. If John Paul is near where he needs to be, if not, I can keep talking about it. Ah, there he is.
Thanks, Steve. Okay, so you saw some of the test cell. I'm going to take you in through some of the manufacturing area. Behind me, you see a hangar. This is mostly storage. We do have some airplane kind of overflow from our installation facility, which we won't get to see today, which is where we do the actual installation of the turbo systems and all of the things that we make when we put them on the airplanes happens at that facility that's another building over. But we do have some of the overflow here, and we have some of the airplanes that are also experimental for other reasons. This airplane is here for a fuel test program. We're going to go inside to this machine shop now. So this is the GAMI machine shop. This is one side of it anyway. This is where we have the CNC machines. CNC stands for computer numerically controlled, and that is where the machines are automatically driven based off of a program that you write to make a part. So again, here's this GAMI ejector component, this fuel injector that I brought with me. This is where we make these, and essentially we have an engineering drawing that shows the profile of this part, and then we have a program that tells which cutting tool to use and follows that profile and cuts that part out, and that happens here in these machines. So here we are with it's what's called gang tool, and I'll show you the inside of one in just a second. This operates off of a stick of brass. It's a bar of 12-foot lengths of different sizes of brass that we load into this thing called a bar feeder. And then the program runs. And as the program runs, it makes essentially half of the part and cuts it off and drops it into this little hopper here. And this hopper has the half-finished part. And then we take that half-finished part like this and move it over to this machine where it's put in one at a time with the finished part in and the unfinished part out. And this machine finishes off the other half, so we end up with the finished part. So this is what I meant by gang tooling. It's a lot of different tools in line, and this plate shuttles back and forth and in and out to cut the part and end up with the part that we want. And that's all done with a computer program that's on the screen here. We have some other machining capability in what's called a vertical machining center. This is a Bridgeport Interact 520. It's an older machine. It's been retrofitted with a computer control. It had an older style control, what they called a Heidenhain TNC 155. It was real limited, and we did an in-house retrofit on this to put a more modern control behind the scenes and give us a lot more capability. And one of those capabilities was the ability to make programs that are very large. Our original control was limited to about 1,000 lines of code. So to put that in perspective, if you give this machine the instruction to take this tool and move it from one XYZ coordinate in space to another, that is considered one move. That's one line of code.
if you make a circle that is a complete arc or a portion of an arc that is on a single radius, that's one line of code, one move. If you do a complex curve, which is a 3D curve that's not a single radius, it's a series of very small steps. Some of those steps are, thousandths of an inch. And those small steps are each a line of code. So you can do a funny shape like this and do all these single lines of code and end up with, 100 lines in just that. So when you're limited to 1,000 lines, that's pretty limiting. We upgraded that so we can do programs. Some of our programs on our molds are 500,000 lines of code or 600,000 lines of code. And that's something that we wouldn't have been able to do without changing that control. So there's a few of those here. This is one of the sheet metal parts you saw in the engineering department. That's the die that makes it. We made that in-house. And then a lot of our exhaust system components are stamped out here. We have a facility that's about a block away that has a big 200-ton press, and we make those dies here to stamp out those exhaust pieces. And as we go out, I'll show you one of those. Now here you can see some of the, as we pass, we'll just see some of the welded components. These are mostly R&D components. And if you look in the background, anytime we're walking by, you'll see a lot of different things that are projects in the work. What's up? Come in. This is our welding department. This is where we put together exhaust components and intake components for these turbo systems. So there's a lot of welding of aluminum and welding of stainless steel. Those are our two main materials here, 321 stainless and 6061 aluminum. So what we have here are some exhaust manifolds and some tailpipe parts or heater parts. So let me show you. Let's look at this real quick. This is the tooling that you saw. This is the stamped piece. And the way this stamping works is this gets cut out and these get welded together. And then that turns into the exhaust piece that you saw on the table over there, and we'll walk by it one more time. Actually, here's a part of it welded together. Real high quality welding. This is something that is taught there at the PTC, and we've had a few of the welding students, in fact, work here for a short period of time. And you can see some of the other intake and exhaust components. This is one of our new parts. This is one of those tip tanks that you saw the drawing for. This one's been cut in half so that we could see the penetration of the welds here. This is actually a brazing operation, and you can see some partially constructed components on the wall there of those. And here's another look at that welded exhaust. Here's this heater core. This is how you get heat from the exhaust system into the cabin. These are all air-cooled engines, so there's no radiators, no heat exchangers, no water-to-air heat exchangers like the car would have. These rely on the exhaust to heat up a manifold, and that air is then pumped into the cabin, and that's where you get your heat. As you climb an altitude in an airplane, you lose about 2.5 degrees of temperature for every 1,000 feet that you climb. So when you get to the altitudes that we fly in turbocharged airplanes, which is the high teens, 15 to 18,000 feet typically, it can get kind of cold up there. It can get below freezing. So it's important to have a good heater, and that's what we're making here. There's 2 for 1, and then that turns into a completed part. Here you can see kind of inside the heater channels. These are little Inconel tubes. Here we'll quickly pass by some of our tip tank parts. This is not where we do the manufacturing and assembly of these parts, but I moved them here so we could just take a quick look. This is a fiberglass nose cone. This is something we make to go on the outside of the tip tank, which is kind of an aerodynamic fairing, and it also has a spot that will later get cut out for a light. So there's lots of fiberglass work that goes involved in this, and then fiberglass grafting this to the aluminum tank, manufacturing of the lenses, manufacturing of the components that go inside. A lot of parts go into a lot of these. A lot of operations go into these parts, is what I should say. Here's the inside of one of those tip tanks. So you can see this is a stamped out shell. This is one of the few things we don't do in-house is stamp this shell out. This takes a large hammer press, which is a big press. It's big. Let's say it's the size, half the size of a normal bedroom. And it stamps these shells out, and then we stamp out the smaller parts in-house, which are these little ribs, and then have these spot welded in place and weld in all these little parts. And then eventually we'll fuse these two halves together. And here's the flange where this mounts to the tip of the airplane or the tip of the wing. And these are, again, fuel tanks for extended range. Here is an overview, just real quickly, of if anybody's been to this manufacturing day that we've had at PTC in the past. I usually come and bring this engine display with me. This is the engine display I take to the air shows. It shows a lot of our components that we either make and some future products. Because it's an air-cooled engine, it has air baffling. This is to improve the cooling. Our fuel injectors, of course, some electronic magneto parts, and then the rest of our turbo system down here. You can see some fiberglass components, some intercoolers. Come to the other side. You can see turbocharger, the oil-controlled wastegate that we referenced a couple of times. So most of these components, all these white and these stainless steel components, are all manufactured in-house. And then all of the system itself is assembled on the airplane here in-house. As we walk through here, you'll see this is a general manufacturing area. This is fabrication. Come around. You can see some manual machines, mill and lathe, a CNC press brake, and then behind us there's a big shear. This is where we make a lot of the components that we weld. Cut a lot of the raw materials to stock size, and do a lot of operations, plus any of the special things we need to do that aren't really production related, like making fixtures, making tables, making whatever tooling we need to make to do a particular job. A lot of that happens in here. So a lot of skill and experience in working with metal. And then we'll finish this off by coming into our electronics area. Like I said, this was sort of just a taste of what we're doing here. There's so much more to see, and hopefully you guys will get a chance to come and see some of those things in the future. But this is our electronics R&D area. So this is not Steve's twin brother. This is in fact Steve again. So here you'll see some of our electronic projects. This is a display for that electronic wastegate controller. This is a demonstration of it. Go ahead, Steve.
Just go ahead and go to manual and then see the motor moving, and you can control the position of the wastegate manually or automatically. All developed in-house. Cool stuff.
Lots of other stuff goes into what we do. A lot of testing, a lot of sort of inventing new ways to manufacture things, inventing new ways to test the things that we've manufactured. In a small company like this, there's a lot of innovation that goes into developing these products, because a lot of times there's things that we're trying to do that nobody's really done before, or nobody's done the way that we're trying to do. So I think we've seen everything we can see in the amount of time we have. But if anyone has any questions or wants to ask us about anything in particular, now would be the time.
Thank you, John Paul. That was awesome tour. Thank you, Steve, for your help on this. Like John Paul has said, this is an extremely inventive R&D process driven company. We're really lucky to have them here in Ada, and appreciate all what you've done for us here at PTC, and appreciate you taking so much time with us today and helping us understand what really goes on at a manufacturing plant. So JP, I got a question for you. It's not in the chat, it's just a question that I have for you. So why choose manufacturing as a career in your mind?
Well, I'll tell you, all of the things that we enjoy in life come from a manufacturing somewhere. A lot of the things that we buy, are manufactured in China, and for economic reasons, that's a lot of the drive for that. But everything, you go through your house, everything that you have, everything that you enjoy, all came from a manufacturing facility somewhere. And it's one thing to be sort of a consumer of those goods, but if you can be on the manufacturing end of those goods, you can appreciate what actually goes into whatever thing it is that you've just purchased. And like you said before, if we bring all that stuff in-house, we innovate those things, we manufacture those things here, that builds the wealth for our country and our community. There's lots of bigger manufacturers in our community that aren't aerospace driven, and those are big companies. You've got Flexingate and Dart and even Leachco, a few of these companies, Ramjack, that really manufacture large scale products that it's amazing to think about the fact that these are in our own backyard, and to be a part of that, be a part of, drive down the highway and see a sign that's out there, and say, somebody was involved in the manufacture of that sign. You're drinking your Kool-Aid out of your Dart cup. Somebody in Ada was in the manufacturing process of that, and that could be you, that could be your family. It's an amazing thing, and it's something that sometimes goes underappreciated by students until they really get out in the world and understand the importance of those things.
Yeah, I couldn't agree more. We are really lucky in our small community to have such great manufacturing happening. So one thing I would definitely pass on to our students and our viewers is that there are opportunities here. I don't know anyone in the manufacturing game currently that isn't looking for some great people. Would you agree?
Absolutely.
Yeah. The opportunity and the demand for great people with good skills is only going to get more and more. Like the first slide that I showed you guys, almost 3/4 of the workforce that's skilled labor will be gone in less than 10 years from the workforce. So we are at a critical stage to get those people trained And of course, Pontotoc Technology Center is here to try to make that happen and to try to support any of the high schools and the community in any way that we possibly can. What was that?
Was very important earlier. You had a slide that said how important the right attitude was. In the manufacturing world, you can train almost anyone to do almost anything, but approaching that with the right attitude, the attitude that you want to work, want to be there, want to learn those new skills, and your future is limitless at that point.
Well, thanks for reiterating that, because that is something that I hear almost everywhere that I go, is that we're going to hire for attitude and we're going to train to do the job we want to do. If they have some skills, it's always better, but we're really going to hire for attitude. That is a common thread in what I hear. Jim Eldridge, how about you? What would you say about manufacturing in Oklahoma, in Ada, even in the country?
So I'd go out there and say, very similar to what you've heard, that manufacturing's changing and it's becoming much more advanced, much more high tech. And with all that said, one of the biggest components that we see is when someone's ready to show up and work, there are jobs available. We know from the data, we know from the job market that anyone who's a good student, good employee will have a lot of success. And so what we're hoping today is that people find things that are interesting and cool, and things that you might want to continue having a passion for down the road. Follow that up and see where that takes you. But there are plenty of very interesting, very competitive jobs for the future of manufacturing. And you've just seen with GAMI today, they do all kinds of different work, from fabrication to R&D to some things on the flow bench and software testing to getting to actually go out and do some mechanical work on these airplanes. So whatever your interest, whatever passion you have in this, there's going to be some place for you in manufacturing in the future. And as we work in Ada to assist our manufacturing sector, we're going to do a lot of work to prepare students like you now to look at some jobs in the future. So we have a great partnerships here in Ada. We have great opportunities between our education partners and our manufacturing partners, and we are happy to assist at the Ada Jobs Foundation. Anything that's schools are working on, or anything that's going on with these companies, we want to connect the two. So
appreciate that, Jim, and appreciate all the work that you do for the manufacturing community and helping us connect with the right people and get the jobs to the town and keep them growing. And of course, we always in the economic development world, want to do whatever we can for the existing companies to expand and to continue to grow and to add value to the community. Anything else in our chat there? Does anybody have any questions? At this point, I would open it up for questions from any of our viewers. If you have something, put it in the Q&A or in the chat. If not, we will wrap this Manufacturing Day celebration, and I truly do believe this to be a celebration.
And Jim, we've got a question in the Q&A. JP, how many employees are at GAMI right now?
Right about 40, maybe 42.
Okay. And John Paul, that's kind of a nominal number that you guys tend to stay at, if I recall. Somewhere in the 40 to 50 range is kind of where you guys are.
It is. As we develop this tip pipeline, we're going to pick up one or two probably.
So
as we develop future product lines, we may pick up a few here and there, but it kind of depends on what that growth looks like.
Sure. Well, like you say, these companies in the less than 50, they're very innovative. Less than 50 employees tend to be very innovative and tend to be very oriented toward the worker to try to make sure that they can they can keep those good workers, because we definitely want to have those people come on and be here for a long time. With that said, I want to thank everybody for participating today. Thank you, John Paul. Thank you, Steve. Thank you, Jim, for being part of this. And thank you to all of those instructors and students and everybody that participated in today's Manufacturing Day. I think it's been a really good, successful event. We are recording the event, and if you guys, you instructors, want to review it later, you'll be able to do that by going to pontotoctech.edu and clicking on the orange banner, and you'll be able to rewatch or show this to your other students. And again, thanks again to Tim Rail and to George Brawley, the owners of GAMI, and appreciate everything that they're doing for us here in the community. Thanks again, everyone.
All right. Thank you all very much. We'll go ahead and stop the recording and end it there.